Hello guys, Alan here. Welcome back to my workshop. This is episode 5 in a series of videos on converting a Briggs and Stratton lawnmower motor into an air compressor, or trying to. You might have gathered from the thumbnail on this video that I've made quite a bit of progress, and indeed I have. I've got some bits and pieces bolted together. But the big question, does it work? Well, follow along and we'll find out. So I had intended to make a cylinder head cover either by machining a solid block or fabricating something, whatever, but it turned out I could buy a finished machined item for less than the raw material cost would be for me here in Australia, so it was a no-brainer. I just had to drill one hole out here though, out to 5/16, because that's the hole that will take an original cylinder head bolt going through to the block. The other 3 holes will only go into my plate, and they're 1/4 inch bolts. So there we go. Hopefully that's the right size hole in the right place. So I've decided it's time for the engine to get used to being called a compressor and its new orientation in life. So I had this left over from something, toolbox tray or something, I don't know. Anyway, it's good enough for what I'm doing here. So I've tacked a couple of supports on, and that's holding the that'll hold the compressor, as I'm now going to call it. That's going to hold the compressor just fine while I get in with the rest of it. These are the ports that I've got to match up into my plate, and I think rather than trying to do anything clever with measurement, I'm just going to scribe them. It's apparent from the fact that they have to be in the right place and the right size. There isn't anything magical about them as far as I can tell. They don't have to be terribly precise. Just a matching hole. So my hope is that if I do the ports like that, I could come back later and machine this pattern around there, but I'm hoping not to do that. Well, that's just averted a disaster. I originally marked the pattern out using the wrong plate, and there you guys don't have them the right way up, you get the pattern wrong, as you can see. So blue marks the holes that I want, and I've got to ignore the other marks. Would have been a disaster to not have picked that up. So I decided my best option for milling the slots in the plate was to set it up on the rotary table, as it was an easy option for clamping and alignment. And I think that the using a straight edge and a square will give me a good enough result. I don't know how well that will show up. So I've got it lined up pretty well, and I'm sure it's going to be good enough for this exercise. So because I can't feed in from the edge, I'll be using a slot drill. I'll have to plunge straight down, and the guy I've got in mind is a 3-flute cutter with a 3/16 diameter. And it should do a slot just slightly narrower than the way I've got it marked out, so then I can ease it over a little bit to clean out to the lines. So that's the plan. Right, well, I've got myself set up to start milling. I did a touch-off operation. I've located the start and end point of each of these 6 slots with the DRO, so I'll be able to drive the location of the cutter from the DRO rather than trying to see where these scratch lines are. This being cast iron, it shouldn't need lubrication for the cutter, but I might put the flood coolant on anyway to wash the debris away. We'll see. Anyway, let's get started. And one thing I forgot to say, this plate's about 9mm thick, so I'll be doing the operation in 3 layers of 3mm depth of cuts. So the cutter did the drilling part of the operation really well. There wasn't any issue with that. But when I started to translate and into the sideways cut, I didn't care for the noise it was making. Initially I think I was working at about 1200 RPM, something like that, and I increased the speed to 1500 RPM, and it was a bit happier with that, but still wasn't very comfortable with it. I think I will put the flood coolant on. So it looks like I've got to forget the flood cooling, because it's actually running off the front down here and it's not being trapped. So I kicked the spindle speed up to 2000 RPM and increased the rate of feed as well. I mean, you're obviously seeing it about 10 times speed here, but when I increased the feed rate, things got a lot better. Well, that looks alright. It's certainly a slot. As far as I can tell, it's in the right place. Right, 5 more to go. There's my 6 slots. They should be fine. Well, let's go and take them over to the job and see how it looks. Probably have to do a bit of deburring too. Well, the slots seem to be in the right place, so I think I'm going to do a dress rehearsal of the assembly now. I'll do a complete assembly, but just won't torque anything down, just in case I discover a reason for pulling it all apart when we get a bit further on. There is one thing which occurs to me though, which is a cause for possible concern. When I did the rebrazing around here to fix the leaking that was going on around the slug, I didn't go all the way through, not thinking that I needed to, but it just, of course, I've actually cut through the slug here, so there is a possibility that I'll have an air leak between these two pieces. But I think even if I do, it won't actually affect the performance of the machine, because that's the inlet side, that's the exhaust side, so both of these things I think will always be at the same pressure anyway, so hopefully it won't be a problem. But I suppose it might try and leak through there and come out through there or something. That might be more of an issue. Yes, thinking about it, to go leakage to get in there and come out. Anyway, it is what it is. Press on and hope for the best. So, yeah, the sandwich is that having a bit of garlic paper, then my plate, and all of its screws. They all sort of need to be the gasket moved. Right. These other guys started. With final assembly, this plate will have to be torqued onto the cylinder block before the rest goes on, because I won't be able to get at the heads of the screws, and the rest of the assembly is in place. That's something I've sort of tried to keep in mind as I've gone along with this lot, is to make sure that it in fact is going to be a doable thing. I numbered these screws too because they're a bit fussy about which holes they're happy in. That was a bit odd. Something made the assistant jump up on my monitor. Anyway, yes, so these screws are a bit fussy about which holes they go into. That's because hang on, that's number 3. I did all of the holes to the nominal size with no clearance, specific clearance, so the screws are all a little bit fussy about where they go, and they've all got to be started before anything is done up, because there really is no margin for messing around. Now all of these countersunk screw heads, I've reset the thickness of the head so that they finish up 0.02 below the gasket, below the valve plate. So they're all just slightly low. I was going to try and get them to just flush, and I thought, well, there's not much point, and I certainly don't want them high, so settle for 2 thou low. That's about it. Now we'll snug these up now. And take this fella out. Let's get this other sandwich on. So first up we have one of these gaskets with one hole drilled out to take the larger screw. And we have this fella, also of course with one hole screw opened up, and we can see those slots line up, so that's good. And the next piece of sandwich filling, that's got a bit of a burr. See if we can flatten that out. So this aluminium shim plate is there to give a bit of room for the reeds to open. Right, so these are the reeds, and I think for the dress rehearsal I'll try to get them in there. Then after that, okay, so now this piece has to go on upside down, and to encourage the reed to stay in position, a little dab of grease under each end, and hopefully that's just enough to hold it in position. Let's try and get a couple of screws in there just to assist with alignment. That one started. That one started. So the sandwich must be somewhere near right. And then we have another gasket. Haven't got the gasket correctly aligned. I think that's the big hole there. It's a fiddle ass thing, this. I certainly wouldn't be doing it to try and make money. Yeah, it's just a whimsical thing to try. Alright, that's going in. Not sure whether the bolt's actually long enough. We'll find out in due course. Now you come around here. I'll have you out. Sorry if my hand's getting in the way here. I've got several things to look out for at the same time. Right. You carry on swinging around. And hopefully something will line up. And get the right screws. Right. So these seem to go on alright. Okay, as for the fittings, this is the intake side, so that's where you'd put a filter and a silencer. And this would be the output side, so I'll be using this to direct the output. Down between the motor and the compressor. I'm not losing sight of the original objective though, which is just to prove that it's possible to make a compressor out of a Briggs and Stratton motor, and I may or may not see fit to spend money to buy things like the air filter and silencer and whatever, because realistically I'm probably never going to use it, so why do that? Right, well, I've got this, let me just change the camera angle. Right, so I've got this thing mounted on a bit of a frame here, and originally I just knocked this up. It's just all tacked, just to hold it in the right position while I was working on it. But thinking about it, it's probably good enough to do what I want it to do, but it will need some bracing, because the when the fan belt tension goes on, or the V-belt tension goes on, it'll try and pull this around. This is stiff enough, maybe, but I'm not going to take a chance, so I've got to put a couple of diagonal braces, one sort of like that and something similar on this side, just to make sure that when the tension goes on from the belt, this thing can this mounting can tolerate it. Okay, looking at what's required to get this to fit, I don't know what the correct name is, but I'm going to call it a fan shroud. I don't know. Anyway, so you can see that the cylinder head, my new cylinder head, is in a different position, and so I need to pull this top down by about 10mm. Now, I'm no sheet metal worker, but I'll see what I can do. But that will also give clearance for the air outlet line. I'll also have to work out how to support it in the absence of the bracket that used to be here or around here for it. Well, I want to keep the original sheet metal work that's used with the motor, because it will help direct cooling air around the cylinder, and that way I won't have to use a pulley with a built-in fan, or at least that's my thinking. So looking at the way this is mounted, there's two bolts here which go there and there, and the third bolt back here, which is actually part of the cylinder head. Well, I'm losing that obviously because I'm throwing the cylinder away. But this front of this piece will need support, so I'm thinking the best option is to put some standoffs on these points here and drill some holes here and support it like that. So then the question is, well, how do I work out where to drill the holes? And I was messing about with measuring and calipers, and I thought, just put it on the milling machine and spot it through. So that's what I'm going to do. I've used the DRO to locate these two posts, and then I'll put the cowl back on, and then with those coordinates I can just drill in the right place. So that's what I'm going to do. I don't know whether you can see in that picture, but there's a line on here which was my attempt to mark the location. I'm pretty bloody close. Anyway, so oh, it's pretty spongy, isn't it? Speed the drill up a bit. I might as well do the other one while I've got that drill mounted. Over to 00. One of the joys of a big milling table is having room to leave all your toys out. So I've still got the rotary table set up from the work I did in the previous episode. Anyway, there's enough space, so why not use it? So let's drill this other hole. Alright, I've got to open these out now. An old elastoplast tin. I have no idea how old that is. I got it from my dad, and my son has been eyeing that off. Something that he wants at some point, but probably goes back to the Second World War or not far past it. When Band-Aids were last put in a tin. There we are, done. The joys of a milling machine and a DRO. So I can take this off now and then make the standoffs which will support this from the top of that post. And take the original cylinder head off for what may be the last time. Actually, while I was taking the cover off, I noticed that the top of these pillars are as cast. They haven't been machined off. I think it's going to help me, if they are in fact machined flat, help make sure my standoffs do in fact point at the sky and not some random direction. Let's give them a very light skim. Same for the other one. Right, at least my standoffs will point straight up now. So I'm going to try to bend the end of what I believe is called the cowl to get the clearance I need around the cylinder head. Now, whether this setup will work or not, I've obviously got no idea, but the logic is to stop the sides from bulging out when I pull the top, and hopefully the material here has got somewhere to go. We'll wait and see. Now I'm probably going to get in the way, I'm sorry about that. Let's see what happens when we pull. Well, it actually seems to be working. Actually seems to be working. So I'm going to go a bit further. I need to get about 10 millimetres. Maybe got 5 or something at the moment, so let's go a bit more. Oh, and that's fouling there, so I need a shallower block. And it'll be a bit hard for you to see, but we do in fact now have a millimetre of clearance under there, which is all that's going to be needed because there's no moving parts. That's going to be fine. So now I'm going to focus on making the bracketry to secure the top. Okay, so I've fabricated the standoffs, made it from 8mm bar, the number 832 thread to match the thread in this boss here, and a bit of the same on the other end for a nut, and a pair of flats that allow a 6mm spanner to get hold of it. I've already Loctited that one in, so we'll now tight this one in. Don't want them coming loose. There's enough Loctite for a ship there. Rid of some of that as it'll go where I don't want it to go. Right, so we'll start turning that in. Right, nip him up. Done. Get rid of the excess. It's not doing anybody any good being on the outside there. Right, another piece of the puzzle complete. So now I can finalise fitting the cowl. So I've added some diagonal bracing to these vertical struts. When the and I've put a couple of rails on just as temporary supports to secure an electric motor. Now this whole lot, I still haven't decided whether it's the permanent thing or not, so everything's just tack welded. There's nothing permanently welded, but the tacks are good enough to see how it's all going to work out and give it a trial run, I expect. So for these vertical pieces, I've put a steel bush in the ends of the tubes so I can do bolts up without crushing. When the compressor's on here, so there'll be a motor pulley here and a compressor pulley there, and the belt tension will try and twist the compressor. So this strut here is designed to take a compression, so that's why it's a bit of tube. But on this side here, with the compressor trying to be turned that way from the belt tension, this side would be in tension. So I've just got a flat strap here, which should be enough to resist that. Yeah, I guess that's about it. Okay, it's crunch time. So it's got oil in the sump now. I've torqued the head and sorted the clearance out around there and got the cowl mounted. And it's time to see whether it works. Well, it sucks. Does it blow? I imagine you can hear that. It's blowing very satisfactorily. So I think it's time to give it a try with the electric motor. This is just a spare motor that's lying around. It's only half a horsepower, so I don't think it's big enough to do the job, but it's big enough to spin this over and see what happens. The pulley size, this motor will run at 1400 RPM, and with that pulley ratio this should run at about 1000 RPM. Probably a pretty appropriate sort of speed for it, but whether this would have the power to run it under pressure, I don't know. I don't know whether the belt's tight enough. Anyway, let's flick the switch and see what happens. Not pretty happy with that for a first run. Of course, it was open both sides, but very encouraging. So the compressor runs, but now I need to see if it can build pressure. And I've got this, I think it's 4.5 kilo or something, gas cylinder here. And I started trying to remove this valve out the top, and boy, is that bugger in there tight. But I had a nut in here, a left-hand thread nut, and impact driver was getting it out. It was working, but then the thread stripped. So I've silver soldered the nut in, and hopefully that'll allow me to finish the job. We'll see. Oh, look at that. Too easy. Alright, let's check out what that thread is and start working out how to connect to it. Right, it turns out that the thread in the top of the cylinder is 3/4 VSP, so we'll clean that thread out with a tap. I'm not sure whether it's parallel or taper, but I guess we'll soon find out. My tap is a parallel. Now, that's as far as it's easily going to go. Hard, pretty hard bugger to get hold of. Anyway, I dare say that will be. I dare say that's good enough. Yeah, it looks pretty good. Okay, so we're ready to test and see if we can build some pressure. So I've just got a bit of copper pipe here with I annealed both ends and put a flare fitting so I can easily take it apart. At this end we've got a bit of a jury rig set up, because whilst I've bought a pressure controller, I don't have the other fitting, the one that has the unloader built into the non-return valve, so I haven't got that, so I have to do it manually. So the air is going to come in here. There's a valve here which I can turn off. Pressure gauge obviously on the cylinder side of that, and then up here I've got a water drain which will also serve to let me unload the pressure from here when I turn the compressor off. Well, fingers crossed, let's see what happens. Oh, getting a little bit of pressure. Motor's working hard. Well, all that lot worked exactly as I'd hoped it would, but the motor, as you could hear it, it was going to stall out. But it still managed to build, what's that, 30 psi? Yeah, What's the scale in the middle? I think the scale in the middle must be bar, so it's built to bar. Well, that's very encouraging, isn't it? So the compressor certainly built pressure, just the motor didn't have the power to go very far. Okay, so I remembered that I had this other motor, and it looks like it was discarded by Noah when he finished building the Ark, but anyway, it is rated at a horsepower, and I guess it would date from an era where manufacturers were honest about their nameplate ratings, but it is still 1430 RPM, meaning 4-pole I think, and therefore not as torquey as the 2800 RPM 2-pole motors they manufacturers generally supply with compressor sets. But I've got it. Not only that, it's on the same frame, same shaft size, so it was very easy, quick and easy to swap it out. So it would be interesting to see how much better it's able to cope with this load than the half horsepower was. So let's give it a try. Let's make sure that's closed, that's opened. Okay, off we go. Okay, well it managed nearly 50 psi, which is a pretty good effort. You could hear at the end though that it nearly stalled out. 3 bar, nearly 50 psi, very happy with that. I'm not in position at the moment of course to properly check out what's happening here and whether there are any leaks. That may prove to be the case when we get up nearer to 100 psi and so on. But on what I'm seeing so far it's very encouraging. But it does also highlight that these motors are way underpowered for what this is capable of doing, and I won't resolve that problem until I get my 4 horsepower Briggs and Stratton petrol engine in here. I'm sure that's going to have enough power and torque to run this thing. But anyway, for now I'm really happy, very encouraged, and yeah, very happy. Okay, so where to from here? I think I've shown that it does work. It is possible to make an air compressor out of a lawnmower motor. I never had it in mind to go into production with it or make an heirloom thing. It was just a whimsy. Can it be done? And I think I've shown it can be. But to go further with this, and I probably will, I need a better power source. The 2 electric motors that I've got are just not strong enough for the job, and I don't feel like shelling out several $100s for a motor just to go further with it. So I originally had it in mind to power this thing using a Briggs and Stratton petrol engine, a 4 horsepower horizontal shaft motor, and I did in fact buy one of those. I sourced it on Gumtree I think, a month or 2 ago now, several months ago. But it needs some parts, and I ordered them, oh God knows how long ago now, a long time ago, and I'm still waiting. So basically I think this project has reached a plateau, and I can't do anything more with it until I can find the power source to take the pressure up to 100 and 120 psi. So it's been a lot of fun, and I will come back to it, but I can't say when that will be. Anyway, I hope you've enjoyed watching it with me, and perhaps we'll rejoin when I've got further works to show. Cheers.